morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we will be using trigonometric models. We're listening to Jessica Mayfield, Blue Skies again. Let's get to it, shall we? All right. So we've already discussed trigonometric models, and we are now going to use them to make some predictions, to model some behavior. This time, it's going to be about the height of the tide above mean sea level on January 24th back to Cape Town. And it is modeled approximately by this trigonometric function. The important thing is T is the number of hours after midnight, and H of T is the height above sea level. Okay, so here we go. And I'm going to move over here and create a grid here so I can model it a little bit better by hand. We're also going to use a calculator, but we should be able to sketch this. All right, so graph H of T for 0 less than or equal to x less than or equal to 24. So this is, again, hours after, T is number of hours after midnight. So I know clearly my amplitude is equal to 3, and my period is going to be equal to 2 pi over 6, which is equal to 12. So that makes for a very nice trigonometric graph. That's a little too thick. Let's go to our normal size. So we'll go here, we'll go to here, and I'll go back a little bit. Let's just go out to here. Okay, so let's start some labeling. And we got an amplitude of 3. So 3, -3. And a period of 12. So 1, 2, I'll do every 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 and 12. So it's a sine curve, amplitude of 3, period of 12. So that means a maximum is going to be here, back to 0, halfway between. Boom, you know your basic sine curve. So it's going to look like that. Okay, and then we do it again. Boom, 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 boom. Nice smooth curve. And there we go. So we've sketched it for y equals h of t. So this is t, and this is h of t. When is the height? When is the high tide, and what is the maximum height? Well, here's the maximum height. It's hours after midnight, so this is going to be 3 a.m. So this would be 3 a.m. And there's another maximum height, isn't there? Let's see. And well, the height is 3 meters. Yes. And that occurs again at 3 p.m., right? 12, 13, 14, 15. Well, 3 hours after noon is 3 p.m. So 3 p.m. and that is also 3 meters. What is the height at 2 p.m.? So 2 p.m., 12 p.m., 1 p.m., 2 p.m. is right here. So the height is about here. So now we need to know what is the height of the tide at 2 p.m. Well, 2 p.m. is right here, yes, and the height is this point right here. Okay, but remember, this isn't a 2, this is a 13, 14, because t is the number of hours after midnight, and this is midnight, the first hour after midnight, second, and so on. So this is 14. So for part C, we have to find h of 14, which is equal to 3 sine of pi times 14 all over 6. And all we would have to do is put that in our calculator. And I will tell you, if you do that, make sure you're in radians first of all. it is approximately equal to 2.60 meters. So the height at 2 p.m. is about 2.6 meters. Okay, so a ship can cross the harbor provided the tide is at least 2 meters above mean sea level. When is crossing possible on January 24th? Well, that means, let's just draw a quick line. I'll make it green. So at least 2 meters above sea level is when the height is 2. So that's going to be these guys right here. Okay, so it's from, let me go ahead and color that in. All of this time here is when the height is above 3 meters. So whatever time is here, and then here and here, so between these two times and between these two times is when it's possible for the ship to be able to cross the harbor. So we can't see those times. We can't figure that out by hand very easily, so we are going to use a graphing calculator. And first thing I'm going to do is set my scale. Always a good idea to remember how to set your scale. I'm going to Window Settings, and I'm going to go a little bit behind 2 hours and a little bit behind over 24 hours past midnight. And I'm going to make my scale 1. And then my Y min, I'll make -4. My Y max, I'll make 4, again with a scale of 1. And we get that, okay? And so the original function is 3 sine pi times x all over 6. See how that looks? Nice, clear model. Okay, and we have to find when it's 2. Okay, so remember, it's only a period of 24 hours. So this is 0. We're on a scale where our tick mark is 2. I thought I'd done 1. I'm not going to go back and check that because this says a 2. So 26, this is 24. So we know our graph is good. Then all we need to do is graph f of x is equal to 2. And then it's these points that I'm looking for. So let's do menu, analyze graph, intersection, boom, boom. Keep doing it. Menu, analyze graph, intersection, boom, boom. Menu, analyze graph, intersection, this guy to there. And menu, analyze graph, intersection, this guy right here. Then I'll clean it up a bit so we can see our points clearly. Move this over here. Okay, so then I'm going to shrink that a bit and put it over in our workspace so we can answer the question. I do this, I like to show you, just to remind you how to use your graphing calculator. Okay, let me scroll this down, give myself a little bit of room. Okay, so what are the times? Well, it is from here to here. So it would be, let's see, 1.39 less than or equal to t less than or equal to 4.61 hours after midnight. As well as 13.4 less than or equal to t, less than or equal to 16.6 hours after midnight. So this is how we can model our graph, use trigonometric models. Clearly you can see it's quite useful. That is all I have. Hope you enjoyed it. And with that, I am out.